So this video is going to be on mathematical proofs and how we prove statements in maths. We start off with a known fact or theorem, then go through logical steps, and then state their proof. So I'm going to look at 3 different questions of how they could ask you to prove something. So first one is prove n squared minus n is an even number for all values of n. So I'm going to start off with a known fact that n squared minus n is equal to n minus 1. Yeah, and I'm going to follow these logical steps. If n is even, then n minus 1 is odd. Yeah, that makes sense. If n is even, then n minus 1 is odd. And if you multiply them together, even multiplied by odd equals even. So that proves that if n is an even number and we do n squared minus n, we get an even. So now we do the same thing for n is odd. So that means we looked at every single number. Then n minus 1 is even. So, and odd times even equals even. Cool. So that's the logical steps. And then we just write the statement. Therefore, n squared minus n is even for all values of n. Okay, next up, you might get questions like this that says prove a statement is with the equal sign that has 3 lines, which means it's always equal to. So all you do is manipulate one side, so the left hand side, and make it look like the right hand side. Okay, so I'm going to do that first. So this is just expanding your triple brackets. So let's do this side. So it's x squared minus 5x add 6x minus 30. That will give me 2x minus 1, just collecting our like terms, plus x minus 30. And now multiply this out. We have 2x cubed add 2x squared minus 60x minus x squared minus x plus 30. Collect the like terms. 2x cubed, 2x minus x plus x squared minus 61x plus 30. Okay, so you can see how the left hand side, it looks like the right hand side, alright? So which is equal to the right hand side, and then we have to write the statement again. So 2x minus 1, x plus 6, x minus 5 is always equal to 2x cubed add x squared minus 61x plus 30. Cool, so we started off with our statement and we follow the logical steps to prove it. Next up, you might be given this, asked to complete the square to find, so they tell you a method to use, so we'll just do completing the square on this. So we could just use the formula from our last videos on completing the square. So which, let me just write that, an squared minus 4n plus 10 equals, or the way I like to do it is I'm going to take out 3 and be left with n squared minus 4 over 3 plus 10 equals 3, and then I'm going to do my completing the square here, minus half of that, 4 over 6 squared minus square that, 16 over 36 plus 10. That equals 3n minus 4, 4 over 6 can be written as 2 over 3 squared minus 3 times, I can cancel this down to 8 over 18, 4 over 9, 4 over 9 times that by 3, 12 over 9 over 9 plus 10. Okay, so what I did there was I cancelled this down, 16 over 36 to get 4. So divide both by 4 is 4 over 9, and then multiply it by the 3 to get 12 over 9. And then you add the 10 from the side, so that equals 3n minus 2 over 3 squared times that by plus, okay, I could divide both by 3 again, so that will give me 4 over 3 plus 2. That'll give me 26 over 3. Okay, so therefore the minimum value, so looking at my thing here, minimum value is 26 over 3. So therefore 3n squared minus 4n plus 10 is always positive. Always positive. You could also do completed square the previous way using the formula that was given in the textbook. Now there is other ways of proving things, such as exhaustive method, that I'm not going to go over, but all that is you just try every number that they've given you the restraints. So for example, if they said prove between a certain integer 1 is bigger than, so if they said something like prove that when n is an integer between 1 and 6, something statement, you could just try every number within this to prove it or disprove it. Or there's another method called counterexample. So you could disprove something by just finding one counterexample of the statement, which will make the statement false.